We can use star delta transformation to simplify the analysis of the current and thereby reduce the amount of math involved in the circuit. That is when you want to do the simplification. So a standard three-phase circuit or network can take on two major forms, which names that represent the way the resistance are connected. So a three-phase network can either be connected in these two ways, either in a star connection or in a delta format. So let's look at the star connection first, then we'll go to the delta. So for a star connection, or T connected, it can either be, if it's like this, it means, so I will choose to use a resistor to indicate that so that you can be fine. Like this, like this, like this. So this is a T connection. This is a T connection. And we label this place as 1, this place as 2, this place as 3. So also I can choose to
low battery
draw
charge
this here. I can draw that there, as you can see. So here you can see that we have a node here, we have a node here. So for the star or the T connected, you can call it either a T or a star. You have it like this. So P, Q, and what? And R. Now, this T connection can be drawn as this if we transform the T connection. We have something like this. So this is 1, this is 2, and this is 3. Now, this is P, this is Q, and this is R. Now, in a three-phase network, you see this point here. In an electrical network, this one gives us the neutral point in the circuit. This one gives us the neutral point in a circuit. That this particular stuff you have here gives us the neutral point in a circuit. That is how come we get the neutral point in an electrical network. So our goal today is how are we go? This is where you get the neutral point. So now, how are we going to deal with circuits, impedances given to us which are connected in this format? How are we going to deal with it? So now, we have some formulas to do the transformation. So if you have a circuit like this or like this, you should know that this T-connected network can be drawn as this in a star, and this star can also be transformed as this in the T domain. So I can say this is a star, and this is the T. Let me call it network. So now, how do we then really use this theorem to solve real problems. How then do we use this theorem to solve real problems? Before I go to the next one, as you can see on the board, you have the star here. Let's also look at the delta. The delta. The delta can be drawn as pi or as a triangle. The delta is either a pi or a triangle. And that triangle, we call it delta. When you are doing your core maths in your school, you say your matrices, you say you have determinant. So you say delta what? Delta 1 over delta, or delta x over delta. I believe we remember this one in our JHS. You say the determinant over delta x. So this thing is called delta. That is what we are doing here right now. So we are representing that network as either a pi or a delta, like a triangle. So let's look at the pi. So pi, like your pi, the pi, 2 pi r, that pi. No, we write pi like this. You get it? This is how we write pi. So we are using stars to make you understand what we are talking about. So it's either it is pi connected or it is delta. It is delta. It is delta. So now, how does a delta looks like? A delta looks like this. I believe you can see what I'm doing on the board. And here,
yes, sir,
we have this.
But I'm not saying anything.
We have this. And we have this. As you saw on the star, this is 1, this is 2, and the bridge here is a 3. So for the star, we have P, Q, and R. For the delta, we have A, we have A, B, and C. Now, if I want to draw the equivalent of this is pi in delta, I will just draw something like a triangle. As I would say, it is delta. You draw it like a triangle. Like this. Like this. Like this. So this is A, this is B, and this is what? This is C. So you can say this is your 1, this is your 2, and this is your what? Your 3. So as you can see, we can transform this into this. We can also transform this into this. Now, let's now come and focus on the star and the delta as the case study here. So let's look at the star connection. A star connection, as I drew earlier, looks like this. And a delta connection looks like this. Just like you are drawing a triangle, where this is A, this is B, and this is C. This is 1, this is 2, and this is what? 3. In this case, for the star, this is 1, this is 2, and this is what? This is 3. So, as you can see, this is P, this is Q, and this is R. You can see. So now, I'll draw something here to show you that we can convert star to delta, and we can convert delta to what? To star. I believe you can see what I'm doing on the board.
Yes, sir.
So we can convert the star to delta, and also the delta to what? Star. So the question now is, how do we achieve this? So to convert star to delta, the formula is as follows. The formula is as follows. A minute. So as you can see that we can convert the star to what? To delta. And we can also convert the delta to star. So to convert the delta to star, I will not really stress you with the proving of the formula. I will not stress you with the proving of the formula, because for you as computer science students, you don't really need the proving. So I will show you the formula that we use to do the what? The transformation. So now, as you can see, let's pick the star as a case study now. The star as the case study. So I'm drawing this. So this is 1, this is 2, and this is 3. This is, don't forget that for the star, we have P, we have Q, and we have R. Let me change the color of the writings of the stuff. Let me use a red color. So P, Q, and R. Now, if you want to transform a star to a delta, if you want to transform a star to a delta, this is how you go about it. I will draw a bigger diagram here right now. Good. Now, I want to transform this star to a delta. Okay? I want to transform this star to a delta. That means I will draw a delta around the star. I will draw a delta around the star. Let me draw a bigger, or let me still use this side. Let me still use this side. So now, I'm using the red. I'm drawing a delta around the star. Please look at this critically. Can you see what I'm doing?
Yes, sir.
Yes, sir.
Yes, sir.
Good.
Yes, sir. We can see it.
Now, remember, for the delta, it is what? A, B, and what? C. A, B, and what? And C. Now, for me to transform the star to a delta. How do I do? Now look at the diagram critically. It is very, very simple. Just understand the principle behind it. Now, if I now see I want to convert a star to a delta, I don't have to stress myself too much at all. I don't have to stretch myself too much. Now, to convert that star to a delta, you know, the unknown for the delta is A, B, and C. So if I say A will be equal to, you can see we have, for the delta, we have P, Q, and R. So you say P times Q, so that will give us PQ plus Q times R, that will give us what? QR plus R times P, that will give us RP. That will give us RP. RP, let me write the RP properly. RP all over what? All over R. All over R. Somebody will ask me, why are we using R? Someone will say, why are we using R? Why are we using R? You can see here that
they are resistors.
not because they are resistors. Not because they are resistors. You see the A here. You see the A. Okay. This A is like, you see this direction. This A is facing this R. Are you there? Can you see the A here?
Yes, sir.
Yes, sir.
The A
Yes, sir.
here is facing
Yes.
this R here.
Yes, sir.
Okay. Now, the numerator is always the same. The numerator is always the same. It doesn't change. So AB. So if the numerator is always the same, that will give us PQ plus QR plus RP all over. Now, who can tell me what would this one be?
Thank you.
It will be Q.
Thank you very much. It will be Q.
Yes.
It will be Q. Now let's write for the C. C. Remember, the numerator remains the same. So PQ plus
Plus
QR plus RP all over what?
P.
P.
All over P. Thank you. Who doesn't understand?
We understand, sir.
You all understand, yeah.
No, sir. Sir, please, I don't understand.
Why don't you understand?
Sir, please, I just joined the class.
If you just join, you can't say you don't understand because you just joined the class.
Please, how the denominator? How did you get it?
The what?
The denominator.
The denominator.
Yes. Can you come on
the-
that again for me?
Okay. Now here we are transforming a star to a delta. Are you there?
Yes, please.
Yes. We are transforming a star to a delta. To get that done, you draw a delta around the star. You draw a delta around the star. When you do that, we can now do the transformation. Are you there?
Yes, please.
Good. So now, the first unknown in a delta is A. The second unknown in the delta is B. And the third unknown in the delta is C. So now, if I'm finding for A, or I'm looking for A, it will be P times Q plus Q times R plus R times P. Now, when you see the A is facing this R is directly opposite the A. So I'm dividing by R. If I'm choosing B, I'll divide by what? Q. If I'm working on C, I'll divide by what? By P. Do you get it now?
Yes, please. Well understood. Thank you.
You're welcome. Okay, so as you can see, this formula is what you can use, or you are going to use for the transformation of any network given to you in star into a delta connection. Are you there? Can you hear me?
Yes, sir. Yes, sir.
Okay, now let's look at an example. Let's look at an example. Now, let's convert. Let's see example 1. Example 1. Let's convert the star network below to a delta. To a delta
Charlie.
network. Okay, so we have this. So we have something like this. This is P, this is Q, and this is R. And say P is equal to 150 ohms. R is equal to Q is equal to 180 ohms, and R is equal to 60 ohms. We have to transform this star into a delta. Don't forget, I said to do that, you need the formulas. Now the formulas, you don't have to chew the formulas on in your head. Okay, so what you do is just draw the delta around the star. Just draw the delta around the star network. Good. Now, you know this is A, this is B. Am I right? No, this is not B.
No.
This is A, this is B. The base is C. Am I right? Good. So if I need A is equal to PQ plus, let me use black marker rather. So if I need A is equal to PQ plus what? Q what?
R.
QR plus what?
R plus
R. All over what?
R.
All over R.
Yes.
Can you see?
Yeah.
So now, Then you can choose to write for the other ones. Or when you get this, you go and do for the second one. So right now, let's put in the formula, the values. Let's put in the values. We need A. A will be equal to P is what? P is 150.
150 ohms.
Am I right?
Yes. 150.
Q is
Yeah.
what?
Yeah.
Times
Yes, sir.
180.
Yeah.
Let me reduce the writing so that I have to expand the screen. Now we can easily write the formula from my head, so we shouldn't worry ourselves much. So A is equal to, from the question, let's write the data out. P 150, Q 180, R this. So P, Q, and R. This is 60 ohms. This is what, 180 and 150. 180, 150 ohms. So now, let's do the calculation. So 150, remember, we are saying PQ, right? So 150 times 180
That'll
plus,
give you 27.
we
27.
can put them in brackets. Okay?
Yes. Yeah.
The next one will be what? Next one will be what? QR, right?
180.
So
Yes.
180
times 60.
180 times 60
Yes.
plus,
Yes.
plus
plus
R
60
and what?
times 150.
R and P.
RP.
So that will be
Yeah.
what?
We just give you 60
150
times 150. 60 times
50.
150.
All dividing what? R. R is what?
R.
Is it R?
60.
60.
Yeah.
60. So now, this will give us what? 150 times 180.
27,000.
20.
7,000.
27,000 plus 180 times 60.
10,800.
10,800
Yes.
plus
And 9,000. 9,000. All divided by 60.
Thank you. 60. So, what would that give us now? What would that give us?
That will give us 144,000.
144,000.
Oh, give
Hello.
us.
37,950.
Sorry, give us 46,800.
Yeah, 46,800.
800.
This is 27. This will be 30.
Yes.
46. Yeah, 46,800.
8,000.
46,800.
Divided by 60.
16. It will be
That will give us
780.
780. 780.
780 ohm.
Yes.
Now, let's go to the B. We need B, right? Remember, you see, at this point, you don't need to struggle. You know the numerator is always the same, am I right?
Yes.
So we can
Yes,
just
sir.
go directly. That's why I like mathematics. B. So let's quote the formula first. What will be the B? That will be Q, PQ plus QR
QR.
plus
R.
RP all over what?
Q.
All over Q. So I like doing things properly. So you can say that PQ plus QR plus RP is equal to what? 46,800. Do you agree with me?
Yes.
Yes.
Good.
Yes, sir.
So therefore, you can say B is equal to 46,800 divided by Q. Q is what?
180.
180. So that will give us what?
260.
260. What will be the unit?
Ohms.
260 ohms. Let's come to the next. Now we have to do that for what? C. Am I right?
Yes, sir.
So PQ
Yes, sir.
plus QR plus RP. Am I right?
Yes, sir. Yes, sir.
Divided by P. We can say recall anyhow you want to do it. But just tell me what you are doing so I know that you are doing what you are doing properly. Recall PQ plus QR plus RP is equal to what? 46,800. So therefore, C will be equal to 46,800
divided by 150.
800 divided by what?
150.
150.
Which is
I'll give us what?
312.
312
312.
ohms. Now, when you are done, you can say A. The first A is what? A is what?
780.
780
ohms.
780 ohms.
780
B is equal to what?
260 ohms.
260 ohms.
C is equal to what?
312.
Good. Now, the question was given in star, am I right?
Yes, sir.
So now you just draw the equivalence in delta. So the star question given to us looks like this. This is P. Don't forget, this is Q. This is what? R. And we are told that P is equal to 150. Q is equal to 180. And R is equal to 60 ohms. They are all in ohms. Now, the equivalent network in delta will be like this. So let me use a different color. Don't forget, your delta network says this place is what? A. This is B. And this is C. So C is equal to 312 ohms. A is equal to 780 ohms. And B is equal to what? 260 ohms. This is the end of this particular question. Any question? Yes.
Please, with the naming of the point, can you name them anyhow? Because I can see the star, we name them clockwise. With the delta, it was anti-clockwise. The star,
if you name them anyhow, okay, you are only going to allocate a different name to a different value. Are you there?
I'm there, sir.
Because if I name if I go A, B, and C, if I go the other way around, I'll end up putting C where the B should be and the other one. So you go for the star, you go the A, B, and C. For the delta, you go P, Q, and R.
Sir, please,
Are you there?
I can't see your screen.
Somebody try sharing his screen. You started that thing again.
Yes. Someone. Who is that?
Samuel Mensah.
Who is Samuel Mensah?
So what I'm saying is, if you are dealing with star, you go P, Q, and R. You are dealing with delta, you go A, B, and C. Is that clear?
Okay, sir.
Okay, so I'm giving you some classwork right now.
Hello, sir.
Yes.
Please, from what I have learned so far, when you made a combination of the star and then the delta, I could see that the formula we derived was a product of what is within a portion. Then when you finish, then you sum them up. Then you divide them by the division. How will you know that this particular place should be over R, this should be over P, this should be over Q? That's where I have a problem.
Somebody asked that question and I explained it. Let me go back there. So let's try and pay attention. You see, can you see the screen?
Yes, I can see, sir.
Good. So if you are converting a star to a delta, you draw the delta around the star. So I need A. Is a product. So P times Q, Q times R, R times P. The opposite to this A is the R. So you divide by R.
Okay.
So if you want P, if you are looking for B, you divide by Q. Can you see it?
Okay.
And if you need C, you divide by what? P.
Okay.
Do you get it now?
Yes, sir. Yes, sir.
So the R is facing the A, the B is facing the Q, and the P is facing the C.
Yes, sir. If I understand you well, it's going to be something like Pythagoras theorem.
Yes.
Okay, sir. Yes, sir. Thank you.
You're welcome. So let's do this classwork. Classwork. Don't forget how I taught you. When I give you classwork, you communicate, use the chat. You can use the mic, but it has to be done in a coordinated manner. So
yes, sir.
Yes, sir.
The star network to delta. So let me draw it very small here. We said this is P, this is Q, and this is R. So here, 6 ohms,
Yes.
5 ohms, and 7 ohms. Let me do this well. Let me write the numbers with the black ink. This is 6 ohms. This is 5 ohms. This is. So convert this to a delta. Your time starts now.
So how do I do it?
Say I'm done.
Say I'm done.
Say I'm also done.
I'm done.
Then please,
I'm done.
then we are all done.
Say I'm done.
Yeah, all done.
Say
Yeah,
I'm
we are
done.
all done. I'm Jeffrey.
Say I'm done.
Hello.
Yes,
Yes, sir.
sir.
Hi, sir.
Yes,
Yeah, done.
Hi.
I'm not seeing conversations going on in the chat section.
Yes, sir.
You
Yeah,
can,
so
you can communicate. Chat. Ask your guys. Are you getting it? What did you get? I got
The
this.
same thing I'm
Uh,
getting.
but make it
Let me see the chat.
audible.
Same thing I'm getting.
Then my below. Chat. Let me see the chat.
Please, I wanted to ask if you can compare our answers to see if maybe some of us got it correct.
Oh, you are free. Compare, discuss. Free.
Say.
Yes.
It's what about the
Is that one?
what about the A, B, and the C on the data network?
I can't hear you.
I'm saying that out of changing the A, B, and the C on the data network.
Sir, please.
As in where you put the A, you put like B, we put B, and where you put the B, we put C. What about that?
Don't change it.
You can't change it too.
You can't change it too.
Oh, okay.
People are getting 21-17.
That's the answer. 21.4.
Not the same thing.
Cosmate, I wanted to ask if maybe, like for example, A, the answer is 17.833. Can you? I was thinking 8 is bigger than 5, so you have to release 1 to the 7, making 8. Or
I'm asking you had you had A to be 15. Let's say you had A to be, if you round, you had A to be 15.929 ohms. I don't understand why you're getting B to be 21.4 ohms and C to be 17.8 ohms. This can someone explain?
When you divide the 107
telling me
by
the
the
B
5,
and C answers are greater than the A answer.
but then it doesn't matter when if A is bigger than B or C.
You see for the, let's say, the numerator is the same, but the denominator that changes, right?
Yes.
So let's say for the numerator we had 1.107.
Yes.
107 divided by 7.
B
Okay,
is
I got it.
by, okay, talk.
I get it now.
Okay.
Please, I want
from
Cinnamons, I want to ask so the numerator, no, like I just changed it and I had the same answer. So would they match me correct? Like I use RP plus QR plus PQ because we know that multiplication and addition is commutative. So that means if I apply it here, is it right or wrong?
But what
For
do
me,
you get for the denominator? What are you saying?
The numerator does not change.
It depends on the numerator you are using for a particular area. So if A should be divided by 7 and you go and do it divided by 6, you actually get a correct answer, but it will be for a different variable. You can get all your answers correct, but let's say A is 15.28. You can get that same answer for maybe you go and put it at B, which will make you wrong. Are you getting it? So you get correct answers, but you are representing them with a different alphabet, which will make your answers wrong. I stand to be corrected.
Please, Cinnamon, you do not get me right. I mean, if you check at the numerator at the top, no, you see that he gave us some formula, which is PQ plus QR plus RP. But we know that in commutative, addition and multiplications are commutative. If you change it another way, you get the same answer. So in that top, no,
what did you get?
Hello.
Hi.
Yeah, my brother, I think you will be right.
Yeah, you will be right. You because that's the same thing I did.
It doesn't change.
You'll
So
be
you
right.
just maintain the denominators.
Yes, yes.
My brother, you'll be right. You'll not be wrong. You'll be right. You get the correct answer because the numbers are the same numbers you are playing with. Okay,
Yes,
it's the same
yes.
three numbers you are playing with. So you get correct answer. You get it correct.
Okay, I get
Okay.
Yes.
You are playing with the same three numbers.
You get it correct.
Yes, you
Because
get it
each
correct.
number strikes true 3 times. If you observe, you will see that each number
Yes, yes.
strikes true. So you get it 2 times. So you get it correct.
Has Masa left the group? Has Masa left the chat?
He's there. He's actually observing what is going on, I'm sure.
To ask him that
Hello.
question, but because he's not.
Hi,
Hi.
Hello, guys. Please good evening. Hello.
Yeah.
Yeah,
Yeah,
hello.
hello.
Hello, yeah. You can talk.
Guys, please. So right now that I joined the class, so now I like
Why
my
late? Why
network
late?
was
Why late?
not that stable. So right now that I joined, so I've seen from the page that that is a class work. Please, is a class work or group work? If I may ask that.
It's a class.
It's a class.
It's a class work.
It's a
But
class
we
work.
can discuss. It's a class
Well,
work.
we are discussing.
I can discuss.
Okay. Okay.
Oh, please, I'm asking, is it advisable to leave your answer? Let's say you had an answer correct, but is it advisable to leave it in a 3 decimal place or a 2 decimal place?
But normally, in the say always tell them
I
to
think
leave
2
it in
is
2
fine.
decimal place.
2 decimal place.
Yes.
Yeah,
Okay. Thank you.
you are welcome.
But one of us told me that if you leave it in 2 decimal place and you are working like when you not get the approximate answer, that sometimes the number will increase.
Please, I want to ask you. When you look at
So,
when you look at
it's advisable to.
It's always 2 decimal place, please.
please, I
2
want to
decimal
ask a
place.
question.
Okay.
Yeah.
Okay.
Please, when you look at C, C is 17.83. I hope that is right.
Yeah.
Yeah, that's right.
Yes, please.
Okay,
Yes.
can't
Yes.
we run it up? Can't we run it up to 8?
If you run it to
Is
become
it?
Yes,
If you run
if you run
to
it,
be
it will be 17.8.
I want to ask if that is right or wrong.
Oh, but the 17.83 is okay.
that's why you should leave it in 2 decimal place so that
Yeah.
it will just get there. You know.
You see,
Normally,
if you
converting
run it, you are going to get 17.8333.
Yes.
The
when the
right
numbers
answer is you
are
leave
like
it
2,
in a 2 decimal place.
Wait.
There's 2
you
decimal
can
place,
leave
then
it
you're
in
okay.
4. But than the 2 decimal place. If you are running it in 2 decimal place, some case like you won't get the actual answer. Sometimes it will run, and if you run it like that 17.83 no, and it's 85 and you run it in when you're working going, by the time you realize they will run it again and add it to the 17 and become 18.
No.
Everything that if you are
That's why you should
No.
leave 2 decimal.
No. If you leave it in 2 decimal place, I think that's the best one. Because
Yes.
that is
like
the first one.
if you run it in 3
Before
decimal places or 4 decimal places,
sometimes if you are using like we have the messages when you are finding mean and you are using the mean to continue working to find the variant. If you are running it into 2 decimal place, end up by getting like 1 to the first digit, which is 17. If you have 17.8, like run it to 2 decimal place, sometimes you get mistake.
my brother, leaving it in
I'm
even
getting you.
3 decimal or
Please
4
don't
decimal or
confuse
5 decimal
yourself.
place, you are right too. But just to make your
You
thing,
are
your
right.
work very simple and
That's
nice.
why
That's why you have always been
if
advised to leave it in 2 decimal places.
work,
You get it?
if you are using the, you won't get me. I say if you are using
The reason behind it is that maybe you might be solving a question, different question,
and you will be asked that
Yeah.
you should use that your answer, and that you've gotten it. Maybe
Yes,
you
that is
had
what I
that
mean.
answer in A, question 1A. Then
That
you
is
say that use that answer to go and answer question B. You get it? So like it will be
that
very
is what I
difficult for you
mean.
to like. That's why you say if you leave it in 2 decimal place, it's very easy to run it up. You get it? But if you
That
put
is
it
what
in
I
3
said.
or
The
4
most
decimal
advanced
places, you'll be
part is that
confused somewhere.
unless you confuse, like if you know how to handle it very well, that will be the appropriate way to be very. You will get it easy.
So you wanted to get it easy, or you want it in the easy way around? You leave it in 2 decimal place. You feel me?
You said?
I said you want it to be easy and very neat for you. You should leave it in 2 decimal place. You feel me?
Like you know, like the four, like if it is more than the 2 decimal place, I like manage 4 decimal place.
But
My brother,
to me, I
my
think
brother.
if you leave it at either one or 2 decimal places, the unit attack, just make sure you attack the unit and you are good to go.
My brother, if you solve
Like
it and you had like
if it's
if you
in
take
homes,
it to
add it.
the
If it's in
there's
this
if you
voltage,
take it
add
to the
it.
standard form and
now,
it is
so
only
now you
1
guys
decimal
all
place,
must take out
hallelujah.
decimal
But
place.
if it is more than 1, then you just convert it to 2 decimal place.
Now you guys are all stick that decimal place, decimal place, decimal place.
Yo, I hear.
But anything what you are saying, it is stated in the question, was make it 2 decimal place or 3 decimal place. So that one doesn't matter.
Yo.
This decimal places.
Eh,
And even now, time I just theory. And even I'm calling and I answer here wrong. But me running 1 decimal place. Instead of signing car.
1 decimal place. We are right too. But if you are taking it to go and answer another question, you will be wrong. If you run it more than 2, you will get it right too. But maybe one thing a bit my favorite was this: send the +1 -1. That's one be but yeah, 1 yen is how you be wrong. So 2 need is standard.
Take like 1 with the pop answer.
Obi data network as at a family. My comment was say this your Delta network data family.
You fool. You fool.
Boys and fooling. So if I may ask, which topic is this?
Hey.
Where
So
from you?
as the second rep for top, you know, see.
Open your book.
Okay, I beg. The star delta transformation. Star delta transformation.
From 48 to 50.
I
Open
can't
that
hear
and
you.
you see the
I beg, if someone
Okay.
beats question, you guys will take time answer the question. I beg you.
But some questions too we for know the ask.
No,
Oh,
you don't
like
know the
maybe the
time
person,
you joined earlier.
yeah, maybe the person
You
didn't join
don't know
early.
the
That's
E-
fine.
time.
if
even
the person is
even
not there
if
before we started the distance.
even
That's why.
even
So
we
sometimes
have
take your
our
time.
handout. We should be
Hello,
going
hello,
through it
guys.
smoothly.
Hello,
Yeah, hello.
hello, hello. Please, I went to the chat and I've seen some answers. Please, are we doing that way from our handouts?
No, it was just an example.
Okay.
It's just an example that we are working on.
Because I went to the chat and I've seen a lot of answers. That's why I'm asking that.
I need to write
Yeah,
your own.
it's a class work.
See, that answers we're discussing. Like we're
It's a
And
class
discussing.
that's so
work.
that
We
we
are
should
going
make
to
it
work
more
it,
intuitive.
get
Like,
So,
your
so
answers,
per,
and then go to answers
if I may ask,
submit it.
per the diagram, per the diagram that they have written
Hello,
in
hello,
the.
guys.
Hello, please, can you hear me, guys?
Yeah.
Oh, we can hear you, boss.
I'm asking that. So we are using the diagram to answer those questions, isn't it, please?
Yes, sir. Yes.
Yes.
Yes,
This
please.
very one. The class work.
Oh, okay.
Hello, guys. Please hear me.
The one under the class work is convected.
The one under the class, yes,
Awurade,
I can see that.
Awurade, wo bɛyɛ
But
kuma.
the other words, please, I can't see it clear. Is it what
Yes, we are
convert
using
what?
the one written classic.
Yes,
Do your
I've seen
thing.
that they've
You get
written
it.
and they have underlined, but I can't see the other one clear. It says convert what? The network to a data. That one I can see, but there's a
they have to
particular word
scroll
I
it up
can't
so
see
that
clear.
one show.
If someone can
Star,
help me for that
star,
word,
star.
They convert star network to a dead.
star.
It's a
Convert the
star
star.
network.
Yes, it's a star.
Star.
Star
Okay,
net.
STAARS. Isn't it stars?
Star.
Star.
Oh, okay.
Are you
Okay.
done? Are you done?
Yes, sir.
Yes, sir.
Okay, let's solve this one. Let's solve it together now. So,
Guys,
when you
can you
have
please hear me, guys? Hello, guys. Yeah, hello. We are listening.
Yeah, so please, I'm able to do the first lesson, but I can't continue. So the first one that I did, I got 15.20, but I don't know how to continue with the rest. Anyone here assist me?
I think Sir is coming
Sir
to
want
you.
to
So
solve.
let's
Yeah, so
Sir
he
is
will
coming to
relax
solve
when
it.
you.
Yes, coming
You have
to
to
so
solve
solve
it.
it.
let's go back to you now.
Keep quiet and listen to the lecturer.
Mute yourself. Oh.
Make everybody
Okay,
mute in body.
so now
Yes, come to solve it with us. Action.
So please, we can't
Hello?
hear. Yeah.
Can you see what
Yes, sir,
I'm
we can
doing?
hear. Yes, sir, we can
Samuel,
see.
please.
Yes, sir.
Nobody to mute me anymore. So PQ plus QR plus RP all over R. That will give us what? 6 times 5. 6 times 5 plus 6 times 7 plus 7 times.
That should be.
So it's supposed to be 5 times 7 instead. For the QR.
Okay, 5. Then 7 times 6 all over 7. All over 7. So that will give us what? The numerator will be what?
107.
107 over 7.
Over 7.
That will give us what?
16.29 ohms.
15.29 ohms.
16.
15.
16.29.
No, it's
No,
15.
15.
15.29 ohms. 15.29 ohms.
15 or 16?
15.
15.
15.2.
15.29
15.
ohms.
Okay, so we have that of A. So B will be equal to PQ plus QR plus RP all over Q, but PQ plus QR plus RP is equal to 107. Am I right?
Yes.
Yes, sir.
So B will be equal to 107 all over Q is what?
5.
5. That will give us what?
21.4 ohms.
21.4.
4
ohms, yeah.
21.4.
So 21.4 ohms. Then let's come to E. E will be equal to PQ plus QR plus RP all over P. That will give us 107 all over what?
6.
Huh?
6.
All over 6.
That will give us what?
17.
70.83. 70 point what?
83
ohms. Okay, so now you can draw this thing now. The first network you are given is this. This is P. Q, and R. The first one is what? What do you get there? 6, am I right?
Yeah, first one you had, yeah.
6 ohms.
5
5
ohms.
ohms.
5 ohms.
And
And
7 ohms.
7 ohms.
Yeah.
So the star equivalent will be this is A, B, and C. So from our analysis, C is equal to 17.83. A is equal to what? 15.29.
ohms.
B is equal to what?
B is equal to 21.4 ohms.
Ohms.
Point what?
4 ohms.
4 ohms.
4 ohms.
So this is it. So now, let's move forward. We are now going to look at delta to star now. Are you there? I'm going to look at delta to star. We've considered the star to delta. Now, delta to star. So, delta to star transformation. So now, when we have a star network, we want to do the transformation from star domain to delta domain. This is what you do. So let's draw the delta network. This is a delta network. Remember, this is A, this is B, and this is C. To do the transformation, you draw a star inside the delta. Remember, for the delta, it is what? P. Am I right? Q. And what? R. So now, for us to get the formulas, it goes like this. If I now, you can say you are looking for P, we need P, we need Q, and we need R.
Yes, sir.
So to get P, P will be equal to A times B, the two here, A times B, all over the sum of A plus B plus C. When you need Q will equal to what? A times C.
Yes.
AC. Here, the denominator is the same throughout. If you need R will equal to what?
B times
BP.
B times C.
So, all over A plus B plus C. So, if I need P, A times B. If I need Q, A times C. If I need R,
Sir,
B
please your screen.
times C. You said?
Your screen, what you're writing right now is hidden in the listen. I can't see it well. It's like scroll up a little bit. Yeah, thank you, sir.
Okay. So now, let's try an example. So you have a delta network of this manner. We are told that for delta, this is A, this is B, C. We are told A is equal to 20 ohms, B is equal to 80 ohms. Sorry, C is equal to 80 ohms and B is equal to 30 ohms. We have to do the transformation from delta to star. So as I just taught you, draw the star inside the delta. It's as simple as that. This is P, Q, and R. You know, to get your P, it is equal to what? A times B. So AB all over A plus B plus C. That will give us 30 times 20 all over 30 plus 20 plus 80. That will give us what? 30 times 20.
600.
600.
600 divided by
130.
130.
130.
That P will be equal to what?
Four point six.
4.6.
4.6 ohms.
4.62 ohms.
4.62 ohms. Now, we've gotten P. Q will be equal to what?
E times
AC, right?
Yes.
AC all over A plus B plus, right? 20 times 80 all over 130. Am I right? Because A plus B plus C is equal to 130. So 20 times 180 will give us what?
1,600.
20 times 80.
That's 12.31 ohms.
20 times 80 is what?
1,600.
600.
100.
Divided by 130. That will give us what?
12.31 ohms.
12.31 ohms. Now, PQR. R will be equal to what? BC all over A plus B plus C, which will give us what?
2,400.
30 times 80 all over 130. 24, right?
Yes.
Yes, sir.
That's 2,400, right?
Yes.
All over 130.
That will give us what?
18.46 ohms.
18.46 ohms. Now, you can redraw the circuit now. So the star equivalent of that network This is P. This is Q. This is R. Q is 18.46 ohms. Q is what? 12.31 ohms. P is what? 4.61 ohms. Class work. Classwork.
Yeah, please can you please scroll it down small?
There.
Can you please scroll it down small?
The example where yeah. Thank you, sir.
Please, we can see it too.
What?
Class
The classwork.
We want to go for the classwork.
So the classwork converts
When you get it, I get me one place. Oh, give it to me. Thank
you. Do the conversion now.
Yeah.
I don't agree with that. Response to the response to the annual. Send out you on to say why because of continue. Because of continue only means me better one over to man. But small girl in there go baby. Ka Simon na buko bag be na buko you never go bag. Yeah.
So I'm done.
Have conversation. Have conversation. It can be asking questions. Ask questions.
You have you to ask questions. You have you to ask questions.
Jeffy, ask questions.
Bro, I have no question to ask.
Okay.
Come over there.
You see, if you say this particular delta star something be easy, that be why. You might just all keep quiet. Let's have better.
As we do the nodal analysis, see how many people they talk.
Master, some of us are down. Oh.
My brother, the thing no hard. You saw them, they mix up.
You say you get delta then star T. Right now we dey talk about ketchup, but now when the master say,
yeah, more ketchup in the TV.
let's have better.
Let's have better.
Ameto, hold yourself up.
Who that? Who mentioned my name like that?
Let's ask questions.
So please, bring this one plate. Bring this one plate.
So it go shock you say fair go ring am, but you no fit answer.
Madam. I come see Bajavana. Ghana. Ghana wangewa. Bana Ghana pa. Umenya bolo anala. On stati fatau una fatau. Bolo ade do tu chuma kala na bajila na ni gamdanya bolo mpela jina minya zigana na bolo.
Who they shout the tongues for there? Hey.
Charlie, you dey class for bless.
Ate.
You tell me.
Yeah. This is before so then no ball. I mean you. Kuda dollar. Bol na kuma. Hello. So that now we pass it.
I think you are done now. So let's solve it. So here we need P. So just draw the star network inside the delta. P will be equal to AB all over A plus B plus C. That will give us 6 times 10 all over 6 plus 10 plus 15. That will give us 60 over
31.
31, right?
Yeah.
That will give us
Yes,
what?
sir.
1.93 ohms.
That will be what?
1.93 ohms.
1.9.
I can't hear you.
1.93 ohms.
1.9.
3 ohms.
1.93.
1.94 ohms.
1.94 ohms.
1.94 ohms.
93.
4
ohms.
Yes.
How is it 4? Or 4?
So PQ. Q be equal to what? A times C, right?
Yes.
So this is P, Q, and R. So A times C.
N times 15.
That will be what? AC all over A plus B plus C.
Yes.
15 times what?
10.
10 all over 31.
Yes.
That will give me what?
150
4.84.
31.
Is that
Give you 150
150
over 31.
over 31.
150 over 31. That's
That's
4.84.
4.84.
4.84 ohms.
okay. PQR. R will be what?
BC over A plus B plus C.
BC, right?
Yes, sir.
Yeah.
That will be what?
6 times
15
15.
15 times
all
6
over
over
31.
31.
Yes.
That will give us
That's 90
90
over 31.
over 31.
2.90 ohms.
2.90 ohms.
2.90 ohms.
2.90 ohms.
2.9.
2.90
90 ohms.
ohms.
2.9 ohms.
90.
Is that 2.9?
90.
2.90 ohms.
2 decimal
90
places.
ohms.
2.90
ohms.
ohms.
Yeah.
Okay, so let's now draw the new our transformed network. So this is P, Q, and R. We say Q is what? R is 2.9. R is 2.90 ohms. Q is
4.84 ohms.
4.84
ohms, yeah.
ohms. And P
1.94 ohms.
1.94. 1.94. So this is the transformation from delta to star and star to delta. This is the transformation from star to delta and from delta to star. So we've come to the end of the class.